in today's note, we are going to take what we've learned so far in this unit and apply it to verifying properties of triangles and quadrilaterals. So basically in this table here, we have different quadrilaterals and different triangles, and we have basically the definition, a sketch, and what is required in order to classify the shape. So looking at, if you're given the actual shape, it might be easier to tell. But if you're given points on a plane or points on a graph and asked to verify that they make a certain shape, it might be a little bit difficult. So I'm not going to go through all of these, but if you're asked to clarify or identify or verify a shape, everything in the far right column is what you would be looking for the given shape, right? So for example, a scalene triangle, find the lengths of all the sides, right? Based on those sides, if they're all different, then it's scalene. If two of them are the same, it's isosceles. If all of them are the same, then it's equilateral. If you're trying to check for a right angle triangle, you're basically going to want to find all the slopes and show that two are negative reciprocals, right? So again, negative reciprocals deals with perpendicular lines. Parallelograms, you're going to find all the slopes on the side or of the sides and show that the opposite sides have the same slope. Because again, if they're parallel, then they have the same slope. Rectangle, you're going to need to find all the lengths of the sides, show that the opposite sides have the same length, and then show that the sides that are beside each other have negative reciprocals for their slope for those 90 degrees. For a square, you have to find all the sides to show that they're all the same, and you need to find the slopes and then prove that there is a right angle in there. For a rhombus, find the lengths of all the sides. Again, they should all be the same. And if they're all the same, then check to see if the slopes form negative reciprocals. If they don't form negative reciprocals, then you have a rhombus. Because a rhombus is basically a parallelogram where all the sides are equal, and a square is the same thing except there's 90 degrees. So if all the sides are the same and there's no 90 degrees, it's a rhombus. So let's just go through some examples just to kind of get an idea of what we would have to do. So in example 1, show that the quadrilateral EFGH with vertices E negative 5, 4, F negative 2, 8, G 6, 2, and H 3, negative 2 is a rectangle. So basically what we want to do first is we want to draw a rectangle. It doesn't matter really how big it is or what it looks like. All we're doing is just drawing a rectangle to help us visualize where the vertices are. So if I'm going to label them, I'm going to put E over here. So E was negative 5, 4, F negative 2, 8, G is 6, 2, and H is 3, negative 2. And so basically we have the high ones up top and the low ones on the bottom. Let's go through and label we've already labeled them. So now the first thing we want to do to prove that it's a rectangle, the first thing that we're going to do, is find the length of each side. So we're going to find the length of each side, and then if it's a rectangle, we should have two that are the same and two that are not. So based off my triangle here, or it's not my triangle, my rectangle, I'm going to find the distance of EF. And again, remember our distance formula from a couple lessons ago. So we have, actually, let me just write out the distance formula first. That way we don't have to keep on rewriting it out. We just kind of do a short form. So the distance between 2 points is going to equal x squared minus, x2 minus x1 squared plus y2 minus y1 squared. And now we're going to go into our points, right? So the first point we'll do, let's say, is the distance of EF, or we'll just say EF. So if we plug our points in, we have -2 minus -5, but minus a negative is plus, so -2 plus 5 squared, and then plus y2, or 8, minus 4 squared. This works out to 3 squared plus 4 squared. And when I simplify everything, it works out to 5. Next, I'm going to look at the one opposite of it. Oops. I'm going to look at the one opposite of it, so HG. So HG, again, we know our formula for the length. So we'll do 6 minus 3 squared plus 2 minus -2, so 2 plus 2 squared. We have 3 squared plus 4 squared, which is the same, and we will get 5. So we know that these two sides are the same length. Let's confirm that our next two sides are also the same length. So if we look at E and H, so E and H, again, distance formula is going to be the same. Plug in my points. So 3 minus -5, or 3 plus 5 squared, plus the next point, so -2 minus 4 squared. We keep simplifying. So 8 squared plus -6 squared equals, and when we simplify, we should get 10. So we found EH, and then now let's double check FG to confirm that it is the same length. So FG, we're going to have 6 minus -2, so 6 plus 2 squared, and then plus 2 minus 8 squared. So we get the square root of 8. So 8 squared plus -6 squared, which is the exact same as what we had, and we get a length of 10. So we know they all have the same, or the opposite sides have the same length. Let's double check and confirm that the adjacent sides are perpendicular. So again, step 2, check slopes. And again, we're going to need to know m equals y2 minus y1 over x2 minus x1. And let's look at the slope of EH, right? So this vertical line, or at least in our example, it looks vertical, but in reality, it may be something different. So the slope of EH is going to equal -2 minus 4 over 3 minus -5. And when I simplify that, I get -6 over 8, which reduces to -3 over 4. My second one, I'm going to look at G and H, or H and G. So again, so I found this one, EH. I'm going to find this one now, HG. Oops. And if they are perpendicular, then I know they formed a 90-degree angle. So when I go and use my slope formula and plug the values in, -2 minus 2 over 3 minus 6 equals 4 over 3 when I simplify it. And I can see that, therefore, EH is perpendicular to HG, and then therefore, oops, too many dots. Therefore, EFGH is a rectangle. So by finding the side lengths of my shape and then checking the slopes to see if they're perpendicular, I've determined that this shape formed with the vertices E, F, G, and H with the points given in the question is indeed a rectangle. Example 2, given A -1, 3, B 7, 1, and C 5, 5, verify that triangle ABC is a right triangle, and then B, determine whether or not ABC is isosceles. So what I'm going to do first, I'm just going to draw a triangle just to be able to label my points. So let's say A is up at the top, -1, 3. B is down here, 1, 7. And C is over here, which is 5, 5. So, first thing I want to do is determine if it is a right angle triangle. So, find the slopes. And if I find that the triangle is, or the slopes of two lines are perpendicular, then I know it is a right triangle. So again, M equals y2 minus y1 over x2 minus x1, so our slope formula. And let's look at two lines. So I'm going to look at slope at AB. So 7 minus 3 over 1 minus -1, and I get 4 over 2, which is a slope of 2. I'm going to look at another line, or the one adjacent to it, so BC. And I can see, okay, so it's using the same slope formula. So BC, so I got 5 minus 7 over 5 minus 1 equals 4, or sorry, not 4, 2 over 4, -2 over 4, which is -1 over 2. And I can see that these two slopes are negative reciprocals of each other. Right? They're flipped and the sign is changed. So therefore, AB is perpendicular to BC. So therefore, it is a right triangle. Next, I need to determine if two sides have, or if it's an isosceles triangle or not. So what I have to do for B is I have to find the side lengths. And this is going to use my side length formula, which I've learned previously. And I'm looking to see if two of those sides are the same length. So again, remember our distance formula, or the distance between 2 points, is equal to x2 minus x1 squared plus y2 minus y1 squared. And now I'm going to look at my sides. So let's look for the distance of AB. So I know my formula, so I'm not going to rewrite the formula out every single time, but 1, then minus -1, so plus 1 squared, and then plus 7 minus 3 squared, square root 20. I can just leave it at that because I should get the same thing or a different square root when I find another side. So BC, using my distance formula, so 5 minus 1 squared plus 5 minus 7 squared. And when I go through and I simplify this, I get square root 20 as well. So I know right now that two sides are the same length, so this should work. However, I want to make sure that it's not an equilateral triangle, so I need to calculate the last side to see how this one compares as well. So I'm going to look for AC. So 5 minus -1, or 5 plus 1 squared, plus 5 minus 3 squared. And when I simplify this, I get square root of 40. So because only two sides are the same, therefore ABC is an isosceles triangle. Finally, with my last one, example 3, determine the type of quadrilateral defined by the following vertices: A2, 3, B5, -1, C10, -1, and D7, 3. So I'm always going to start off by drawing out a shape just so that I can determine or label out my points roughly where they should be. Right? It's to help us visualize where they are. So you do want to have some sort of plan with where you're putting them to kind of make sure that they line up. So I have A here. I'm going to put 2, 3. B here, or sorry, D here, which was 7, 3. And the reason that I'm putting them there is because they do have the same y value, so they should be paired up. B is over here, 5, -1. And C is over here, 10, -1. So again, the y values are paired up. If you wanted to, you could realistically take this and rotate the entire thing. I don't know if I can do that on here. If it helps, you could rotate it like this so that the pairs are lined up. But again, you're just trying to do it to see where roughly they line up. Oh, now I got to get this back. And again, you can always plot them out roughly where you think they are on a grid, and then just kind of connect the lines to see. But to determine the type of quadrilateral, what we want to do first is 1, find the side lengths. Because looking at the quadrilaterals, if we find the side lengths, that's a good place to start to determine what type of quadrilateral it is. So to find the side lengths, we have our, let me write down our side length formula again. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to find the side length of AB. So here I have 5 minus 2 squared plus -1 minus 3 squared. So I get the square root of 3 squared plus -4 squared. And when I calculate that, that should get 5. If I look at side DC, so again, just looking at the pair opposite of it, I'm going to have 10 minus 7 squared plus -1 minus 3 squared. So I have 3 squared plus -4 squared, which I do see is the same as the last one, and I get 5. So I know that these two sides are the same. So it's narrowing down. I could have a rectangle, I could have a square, I could even have a rhombus, because again, these two sides are the same. So I still need to go through and find the other ones. So BC, again, I know my formula. So 10 minus 5 squared plus -1 minus -1 or plus 1 squared. So I have 5 squared plus 0 squared, which works out to 5. So I see that 3 sides are the same. There's a good chance that the 4th one's the same, but just to clarify, I need to go through, or to verify, I need to actually find out. So when I go through, so for AD, so I have 7 minus 2 squared plus 3 minus 3 squared equals 5 squared plus 0 squared, which does equal 5. So I know that it is either a square or a rhombus, right? Because all the sides are the same, so those are my only 2 options. The other thing I need to do now is find the slopes. Once I find the slopes, then I can determine if it's a square or a rhombus. If it's a square, my slope should be negative reciprocals of each other. If they are different, then it will be a rhombus. So again, for slope, remember slope is y2 minus y1 over x2 minus x1. So the slope of AB is going to equal, if I look back up at my points, AB, so we have -1 minus 3 over, I'll bring it down, over 5 minus 2. I get -4 over 3. When I look at the slope for BC, so again, if I look at it, I found AB. I'm going to find BC because they're adjacent sides. So if they're 90, again, that means they form that, or if they're negative reciprocals, that means they've created that 90-degree angle. So when I do BC, I should get -1 minus -1 or +1 over 10 minus 5, which gives me a slope of 0. So what we can say in the end is, therefore, all sides are the same length, but no perpendicular slopes. So A, B, C, D is a rhombus. So all the sides are the same, so that narrowed it down to a square or a rhombus. The slopes are not negative reciprocals, so this shape is a rhombus. And again, the main thing from this note, none of the math is new. It's all math that we've already done in our previous notes, or back in grade 9, such as the slope, but we're just using what we know from analytic geometry to help us determine if points given to us on a plane form a certain shape, specifically triangles or quadrilaterals. And again, you can use this table as a reference to figure out what you need to find in order to verify a certain shape.